Hi, welcome to another video of Facts World. In this video we will talk about how we can time travel, or if that possible. So without wasting time, let's get started. In 2009, the British physicist Stephen Hawking held a party for time travelers. The twist was he sent out the invites a year later. No guests showed up. Time travel is probably impossible. Even if it were possible. Hawking and others have argued that you could never travel back before the moment your time machine was built. But travel to the future? That's a different story. There are few ways to time travel in future according to scientists, so let's discuss about them. 1. Time travel via speed. This is the easiest and most practical way to time travel into the far future. Go really fast. According to Einstein's theory of special relativity, when you travel at speeds approaching the speed of light, time slows down for you relative to the outside world. This is not just a conjecture or thought experiment. It has been measured using twin atomic clocks. One flown in a jet aircraft, the other stationary on Earth. Physicists have shown that a flying clock ticks slower because of its speed. In the case of the aircraft, the effect is minuscule. But if you were in a spaceship traveling at 90% of the speed of light, you'd experience time passing about 2.6 times slower than it was back on Earth. And the closer you get to the speed of light, the more extreme the time travel. The highest speeds achieved through any human technology are probably the protons whizzing around the Large Hadron Collider at 99.9999991% of the speed of light. Using special relativity, we can calculate 1 second for the proton is equivalent to 27,777,778 seconds, or about 11 months, for us. Amazingly, particle physicists have to take this time dilation into account when they are dealing with particles that decay. In the lab, muon particles typically decay in 2.2 microseconds. But fast-moving muons, such as those created when cosmic rays strike the upper atmosphere, take 10 times longer to disintegrate. 2. Time travel via gravity. The next method of time travel is also inspired by Einstein. According to his theory of general relativity, the stronger the gravity you feel, the slower time moves. As you get closer to the center of the Earth, for example, the strength of gravity increases. Time runs slower for your feet than your head. Again, this effect has been measured. In 2010, physicists at the U.S. National Institute of Standards and Technology, NIST, placed 2 atomic clocks on shelves, one 33 centimeters above the other, and measured the difference in their rate of ticking. The lower one ticked slower because it feels a slightly stronger gravity. To travel to the far future, all we need is a region of extremely strong gravity, such as a black hole. The closer you get to the event horizon, the slower time moves, but it's risky business. Cross the boundary and you can never escape. Gravity can slow down time. And anyway, the effect is not that strong, so it's probably not worth the trip. Assuming you had the technology to travel the vast distances to reach a black hole. The nearest is about 3,000 light-years away. The time dilation through traveling would be far greater than any time dilation through orbiting the black hole itself. The situation described in the movie Interstellar, where 1 hour on a planet near a black hole is the equivalent of 7 years back on Earth, is so extreme as to be impossible in our universe. According to Kip Thorne, the movie's scientific advisor. The most mind-blowing thing, perhaps, is that GPS systems have to account for time dilation effects. Due to both the speed of the satellites and gravity they feel, in order to work. Without these corrections, your phone's GPS capability won't be able to pinpoint your location on Earth to within even a few kilometers. 3. Time travel viaduct wormholes. General relativity also allows for the possibility for shortcuts through space-time known as wormholes, which might be able to bridge distances of 1 billion light-years or more, or different points in time. Many physicists, including Stephen Hawking, believe wormholes are constantly popping in and out of existence at the quantum scale, far smaller than atoms. The trick would be to capture one, and inflate it to human scales, a feat that would require a huge amount of energy. But which might just be possible, in theory. Attempts to prove this either way have failed, ultimately because of the incompatibility between general relativity and quantum mechanics. 4. Time travel using light. Another time travel idea, put forward by the American physicist Ron Mallett, is to use a rotating cylinder of light to twist space-time. Anything dropped inside the swirling cylinder could theoretically be dragged around in space and in time. In a similar way to how a bubble runs around on top your coffee after you swirl it with a spoon. According to Mallett, the right geometry could lead to time travel into either the past and the future. Since publishing his theory in 2000, Mallett has been trying to raise the funds to pay for a proof-of-concept experiment, which involves dropping neutrons through a circular arrangement of spinning lasers. His ideas have not grabbed the rest of the physics community, however, with others arguing that one of the assumptions of his basic model is plagued by a singularity, which is physics speak for it as impossible. So these are some ways to time travel into future, so I hope you guys like this video. Give your feedback in comment section.